What we were talking about yesterday, we talked about right prisms. There's a formula that we like to use because it works for all the shapes, for the TSA, the total surface area, and then there's a formula here that we can use for volume. Now, we already touched on that for this word prism, yeah, okay, that basically means a shape that is now elongated into a prism. So we have a triangle and we elongate it along there. So that's our height. So that's what makes it a prism. So there's a circle and then we're going to elongate it down and then that's what makes it a prism. If it's a square, that's my base shape. We're going to then elongate it along into 3 dimensions and that makes it a prism. Okay. So when we going through here, so I'm going to skip ahead quickly. Okay, a cylinder. Okay, so the first thing to recognize, what's important, okay, for this, a cylinder, what's the base shape going to be? Your base shape is a circle, quite easily, okay. So we want the surface area, volume, and capacity of the following cylinder. Surface area, so we want the TSA, we're going to follow that formula. The volume, we're going to follow our volume formula. And then capacity, we're going to have to convert it over. So all they told us is that the radius here, okay, is 5 centimeters. And then my height here is 10 centimeters. And that's all we need. That's all the information we need. So if we follow for the TSA, the total surface area is equal to, what's my formula quickly again? What's it? It's my 2 times my base area, okay, plus the perimeter of the base, okay, multiplied by my height. And where do we get the height? The height is the thing that's elongated it into 3 dimensions. Now, what's special about the perimeter of the space? What's another word for the perimeter of a circle? The circumference. Okay, we need to know how to do that. So, let's work it out. So, we're going to say 2. Now, the base shape, the base area is a circle. So, the area of a circle is pi r squared. And my r is going to be what? It's 5 squared. Okay. Plus my perimeter. What's the formula for the circumference of a circle? Pi times the diameter. Now, if my radius is 5, what does my diameter going to be? 10. Exactly. Pi times 10. And my height there is also going to be 10. So, plug that into our calculators. What do we get? What do you get? What do you get? Quickly, now, quickly. Two times pi times 5 squared plus.
Sorry for the interruption, Mr. Strummer. Please indicate where you are.
Okay, I get 150 pi. Anyone else get anything different? You get error. Okay, so if you got error, I got a little bit error. So when you're pushing in your pi value, okay, push next, so the arrow, and you'll probably see where it ended up because your pi is usually over there. It's also times 10 to the x. If you didn't push shift properly and you push that instead, you might have got an error there. So do that quickly, fix that. Okay, so that is in 2 decimal places always. So 471.24. Okay. If you get the error. Okay, so what you're going to do, you push your arrows left or right. Okay, and it's going to, the little cursor, it's going to blink, and then that's where the error is. Okay, and you can see where the problem came. Okay, so look, check. If I do that, you see it's an error. It's a syntax error. So I'm going to push an arrow. There, you see it's blinking there. I put that little times 10 there instead of a pi. So I'm going to delete it. Shift, I'm going to put pi. There we go. Right. Okay, come quickly. So, what's my unit going to be? It's going to be centimeters what did we work out? We worked out area. So what's it going to be? It's going to be squared. See, you're putting a times between your pi and 5. There we go. Okay. So now we need to work out the volume. Okay. So the volume is going to be equal to, what's my formula for my volume? It's my base area, okay, multiplied by my height. So my base area here is going to be pi times 5 squared, okay, multiplied by what? My height, which is 10. Yes. So what's it going to be there? I'm going to get 250 pi. Okay, which is what? Okay, the volume 785.2 decimal places 40. Because it's a 9, you round up 2 decimal places, so it's going to be 40.40. Pardon? Yes, because if you want 2 decimal places, you need to have that 0 there still. It's 2 decimal places. Because if you just say the 4, it means you've rounded to 1 decimal place. And then there's a rounding error. Okay. So what's my unit going to be? Centimeters cubed. And now remember, so now they want the capacity, the formula for capacity, the conversion. 1 centimeter cubed is equal to 1 milliliter. So what's it going to be here? If they've got 785.40 centimeters cubed, how many milliliters do we have? Exactly, it's a 1-to-1. So we're going to say, therefore, my capacity is equal to 785.40 milliliters. All right. Okay, any questions about that one? We're getting it. All right, so look at the next one now. Okay, it's a word sum. We're going to have to do some stuff. So they said, yeah, a cylindrical pool, okay, was dug in your backyard with so on and so forth. Now, what is my base shape going to be? It's a circle, yes. The word cylinder is there. It's a cylindrical pool. So we're going to find, they've given you the diameter of 12 meters and a height of 2.5. So if I can try and draw it out quickly, let's see if we can do that. Just give me clips. There we go. Whoop. So there's it there. There's another one there at the bottom. Okay. And let's draw some lines in there. Okay. Very, very accurate pool. You agree? I agree. I think it is. So, okay. So they told us that the diameter, here is going to be 12 meters. Okay. And then my height here is going to be 2.5 meters. The inside of the pool must be tiled. Calculate the total area of the pool that must be tiled, the volume and the capacity in kiloliters. Now, this one is going to be a bit weird. Who can tell me why we're not going to use my TSA formula? We're going to use an adjusted version of it. Okay. Tell me, why do you think we're not going to use it? Okay, who can think? Exactly. Because there isn't a surface. You need to get into your pool. You can't have it completely tiled. So it's only going to be the tiles at the bottom. Okay, so one of the circles and then the tiles on the side. So then that's the other side. So have a look here. My total surface area formula usually looks like this. 2 times my base area, okay, plus my perimeter of my base times my height. But now we only need to tile the bottom of the pool. You can't tile the top of the pool because then it's not a pool. You've made a weird, like, cage out of tiles. That's weird. We don't want that. So, we only want one of the base area. So, we only want this. So, look, I'm going to put it in a light color. So, we only want that tile there. There. So, there's the base area. And then that there. So, we only want that there. So we don't want the lid. So imagine like a cup, okay? We're trying to find the surface area of the inside of the cup. So because there's going to be a cup, there's a water part where you can get things in and out. You're not going to calculate that. You only want the inside. So that's why we don't say two base area. We just say one base area. Okay, so that's where the tricky word sums come from. So the base area is going to be pi r squared. Now, what is my radius here? What's my radius? 6. Why do we know it's 6? Yes, it's half of the diameter. So it's going to times 6 squared, okay, plus my perimeter, another word for perimeter of a circle, circumference. And the formula for circumference is pi times my diameter, which is 12, okay, and times my height. What's my height going to be? 2.5. All right. So plug that into your calculator. What do you get? So I'm getting pi. Okay. Do you get something like this? I'm getting here 66 pi, which is equal to 207.35. Do you get something same, something different? You got 144 pi. 154. Did you maybe times instead of plus? Oh no, jeepers. Are you squaring your pi, maybe, instead of squaring the radius? Oh, so you got 230 and 226 or something. That's something weird. You square the 6. 6 times 6 is? 36, yes. Okay. So I just put 36 in my calculator. Okay. So that's my area. Now, do you notice it's not going to be, it's not all the things, it's only the inside. So it's almost like you have a cup. Now, okay, calculate the total area of the pool that must be tiled, the volume and the capacity in kiloliters of the pool. Okay, so let's work out the volume first. So the volume is equal to my base area, okay, multiplied by my height. So my base area, it's going to be again pi times 6 squared multiplied by my height of 2.5. Okay. I get 90 pi. Anyone get anything different? 90 pi. Yeah.
95, yes. I
Yes.
was saying 95.
Oh, okay. No, sorry. I'm mumbling. Doing funny things here. Okay. So we're going to have 282.74. And then what's my unit? Meters cubed. Now, capacity in kiloliters. So that's that one we had to draw in. So let's go back. I'm going to show you. Capacity in kiloliters. Here's it here. There we go. So 1 meter cubed is equal to 1 kiloliter. 1 centimeter cubed is equal to 1 milliliter. Now there's another one that we don't really deal with. But which one's missing? So we have a milliliter and a kiloliter. What's in the middle of a milliliter and a kiloliter? Just a liter. No. So 1 liter is equal to 1 decimeter cubed. But we don't deal with that. We just do centimeters and meters cubed. Okay. What's wrong? Get our tests. Yeah, I've got it here. Okay. We nearly finished. Let's go quickly. Okay, so what's it going to be here? So my capacity, no? What's it going to be? 282.74. And then remember, it's a 1-to-1, so 1 meter cubed is equal to 1 kiloliter. They want it in kiloliters, so we must have it in meters. We already have it meters cubed. Because it's 1-to-1, all we're doing is changing the unit. Kiloliter. Okay. Any questions about that? No. Okay. So, there we go. Look at this. What am I highlighting here? What's this? Homework. Yes. So that's it there. Okay. The homework. Okay. Tomorrow we're going to start finding the height, radius when they're given the volume. So it's the same thing. We've been given the area in the previous chapter. We have to find the distance and the lengths. Now we have to find the height or the radius when given the volume. It's the same things backwards. Okay. Any questions? No.